introductory video for acids, bases, and salt. From that video, do you know any example of an acid, or do you know any more examples of bases? What are acids? What are bases? What are salts? That's what we're going to be looking at right now. Now, an acid, based on the pH scale, it is any substance that has a pH of less than 7. So right here, you're seeing a pH scale. You're seeing from 7 right down to 0, and you're seeing right up to 14. So anything below 7 would be an acid. So that's how we can define an acid. That's one way how we can define an acid. Now, an acid neutralizes a base. So whenever you react an acid with a base, just as we did earlier, you will get a salt and water. So salt and water are usually formed when we react an acid with a base. So it neutralizes bases. Now, an acid forms H+ ions in solution. What is an acid? It's also corrosive, meaning it will react with metals, all right? No, it's a good conductor of electricity. So acids are good conductors of electricity. Now, an acid usually tastes sour. Not sending you to go and taste it now, but an acid usually has a sour taste. Now, acids also will produce hydronium ions whenever you react them with water, or whenever you add water to an acid, hydronium ions will be formed. So hydronium ions are formed whenever you react acids, or whenever you put acids into water. Whenever you form a solution with it, you're going to get hydronium ions from that. All right. We have what we call weak acids versus strong acids. Some acids are weak acids. Example, your vinegar, that's a very weak acid. And we have strong acid, which such as your hydrochloric acid. It's also found in the stomach. We're going to talk more about that later. Weak acids do not ionize completely. Example, your acetic acid, boric acid, nitrous acid, phosphoric acid, sulfurous acid. While your strong acids, they ionize completely. Example, your hydrochloric acid, your nitric acid, your sulfuric acid, as well as your hydrochloric acid. Common acids. So here are some examples of common acids. You have your Pepsi, that's an acid. Acid found in your lime or your lemons. Acids found in your batteries. So HCl, hydrochloric acid, which is stomach acid, sulfuric acid, car batteries, nitric acid, which are in explosives. We have acetic acid, which is your vinegar found in the home, carbonic acid, which is in your soda, and phosphoric acid, which we use in flavorings. It's important that you know the formula listed right here of these common acids. What is a base? A base is a substance with pH greater than 7. So once a substance has a pH greater than 7, then it is a base. Base usually feels slippery. So like your soap, whenever you're rubbing your soap on your hand, you realize it has a slippery feeling. So therefore, that's a base. Your bases also sometimes they taste bitter. They usually form hydroxide ions in solution, and they neutralize acids. They also conduct electricity. Common bases, we have sodium hydroxide, very common base. It's found in your soaps or your drain cleaners. We have magnesium hydroxide, which are antacids. We have aluminum hydroxide, antacids, deodorants. We also have ammonium hydroxide, or what we call ammonia. All right, so here are some examples. We have your household cleaners that they're found in, your soaps, your antacids, your deodorants. Now here we can find the pH of some common substances. pH is very important. So if you look at your hydrochloric acid, it's 0. which means that it's very strong. So the closer you go to zero is the stronger the acid is. So right now, hydrochloric acid is right at zero, which means that it's a very strong acid. We have gastric juice, which is at 1.6. We have your lemon juice at 2.2. So these are all acidic. We have your vinegar at 2.8. Now, if we should go over, we have some other substances that are there. I want you to think about substances which would be found on this pH scale. For example, what other substance would be at 14? Give me an example of a substance that would be at 7. Now, it's important to note that substances with a pH of 7 are usually neutral. For example, your water, that's usually a neutral substance. We have soda, oranges, apples, tomatoes, coffees, all on the acidic part. We have your soil, bread, potato, urine, milk. Now over here now is where we have the pure water. Now you thought about yours, so I'm going to give you some answers. Drinking water, we have blood with a pH of 7.4, detergent at 8 to 9. Bile, which is 8. We have seawater between 8.5. We have milk of magnesia at 10.5, ammonia at 11, bleach at 12, very basic substance. And we have our lye, which is our sodium hydroxide, which is 14. It has a pH of 14. What that means is that sodium hydroxide is a very strong base. So the closer you are to 14 is the stronger the base is, and the closer you are to 0 is the stronger the acid is. Hope that's clear to you so far. Now your pH paper, we use our pH paper to test the acidity or basicity of a substance. So sometimes we call it our litmus paper. So what it does, it changes color to indicate a specific pH value. So your litmus paper, if it turns red, it means that the substance is acidic. And if it turns blue, it means that it's basic or it is a base. So we have buffers. A buffer is really a solution that resists changes in pH when small amounts of acids and bases are added. So if you add small amounts of acids or bases to solutions or to buffers, they will resist the change. So sometimes it's important for us to have the pH in control, such as heartburn, planting vegetables and flowers. You need a controlled environment. Fish tanks and ponds, your blood, that is very important that the pH is confirmed or controlled rather. And also swimming pools. Now, recently there were some things going around that you should drink this to alter the pH of your blood or anything like that. But those are just false theories going around. There's nothing that you can do. It's naturally controlled. It's controlled by itself. All right. Now, acids and bases in solution. Hydrochloric acid, when we add water to it to make a solution, what we actually get, we get more hydronium ions, which means it becomes more acidic. So one thing I always tell my students in the lab is that when you're in doing an experiment and let's say acid accidentally touch you, please ensure that you practice safety measures when doing experiments around acids. A little concentration of a little acid can do severe damage. So we don't want that. But if let's say worst case scenario and a piece of it, a little of it spill on you, you don't want to run and put water on your hand because that's gonna actually cause it to become more acidic. It will produce more heat and it will actually make you worse. So try to stay away from that. All right. For sodium hydroxide in water, it actually becomes more basic if you put water as well because more hydroxide ions are going to be formed. Now, acids and bases in solution continuing. If you should react hydrochloric acid and sodium hydroxide, what you're gonna get is salt and water. The name of this salt is sodium chloride and water, which is H2O, all right? So acid plus base will yield a type of salt and water. We call this a neutralization reaction. Now, a neutralization reaction is the reaction of an acid with a base to produce salt and water. Some more examples include your sulfuric acid reacting with sodium hydroxide to produce a salt and a water. All right. Now, acid rain. Acid rain is pollution in the air by sulfur dioxide, carbon dioxide, nitrogen dioxide, combining with water to form various acids. More acids. Acid rain. And these are some of the effects. Acid rain can actually harm your fish. Causes holes, damage the environment. So rapid changes in the pH because you're suddenly creating a more acidic environment. So it's now acid rain. It can kill organisms in lakes and streams because you're changing their habitat. You're changing the pH of their habitat. Can also kill plants and create sinkholes, as you were seeing in the photo. This is actually a sinkhole in Oakview Cemetery. Very bad. You realize that there's no sinkhole and the graves are just going and it's just bad. So acid rain is very bad for the environment. These are some more snippets of effects of acid rain in some countries. Now, what is a salt? A salt is composed of a negative ion of an acid and the positive ion of a base. So earlier you heard us talking about an acid reacts with a base to form salt and water. So what happens is that the negative ion of an acid will combine with the positive ion of the base. So one of the products of a neutralization reaction would be, or we have potassium chloride, sodium chloride, magnesium sulfate, sodium phosphate. So a salt is really one of the products of a neutralization reaction, salt and water. These are the examples: your potassium chloride, your sodium chloride, your magnesium sulfate, and your sodium phosphate. Now, this is the end of our video on acid, bases, and salt. The end of our video. Please remember to subscribe if you haven't done so. If you have any questions, please comment in the comment section. You're now going to have a little quiz on acids, bases, and salt. So click the link below for the quiz and let's get started. Thank you so much for watching. My name is Felisa Rickett. Thank you for watching. See you in the next video. Remember to like and share with somebody who you know is doing chemistry at this moment. Have yourselves a lovely day.